Okay, let's get going. Thanks for joining us for this next session, which is going to be a quick tour around some of the options that AWS offers for developing, deploying, and operating modern applications in the cloud. And of course, the first thing I'm going to do in this session is explain precisely what modern applications are. But before we do that, I just want to pre-introduce my guest who's going to be joining me on stage later in the session. It's Anne Ledwith. Anne is a director in software engineering at Sage, and for those of you that don't know, Sage is the largest independent software vendor headquartered here in the UK. I'm excited to have Anne join me midway through the session to talk a little bit about some of the work that they're doing over at Sage. So, modern application development. A lot of you will, of course, have realized that for organizations of all types, delivering products and services through software-based channels is becoming increasingly important. And in doing this, what our customers are seeking to do in the vast majority of cases is compress down the time that it takes them to go from idea through an experimental loop into feedback. It was Charles Darwin that said it's not the strongest species that survive, but those species that are most capable of adaptation to the environment, right? And that's precisely what we see in software engineering and in successful software products today. We see products that are not built over months or years, but products that are built over weeks or months. And that enables organizations to take much more frequent decisions about the direction that they wish to head in and stay in a position which is much more closely aligned to the needs of their customers. That's one of the reasons that organizations are seeking to compress this innovation and experimentation cycle. The other thing that we try to do a lot at Amazon and at AWS is enable this experimentation at scale. It's a truism that the only way to have more successful experiments is just to have more experiments, right? Because if you already know the outcome before you start, then those things aren't genuine experiments. They're just like high school science, repeating work that others have already done. And one of the great benefits of cloud computing in AWS, of course, is that it dramatically reduces the collateral damage from failed experiments. You won't be left with physical assets hanging around that are unused but still sitting on your balance sheet in the event that a product that you've built is not successful. You can return those resources back to the pool, back to the cloud, stop paying for them, and we can use them for something else, another customer in a lot of cases. So the cost of experimentation is dramatically reduced if you are building in the cloud versus traditional delivery models. This is really important when you consider that the landscape of IT today has changed a lot. IT used to be pretty static. It would be serving constituency of users inside a business or maybe a fixed pool of users that were external. But we wouldn't face this highly interconnected landscape that we see today with many, many different users for our systems and services, many different types of interfaces that we might want to expose to customers and to partners, which drives a lot more demand for technology. It drives a lot more complexity, and it also drives higher velocity. And we see customers trying to service these new needs that exist within this more complicated systems landscape. So trying to become more data-driven, make better decisions based on data, often at data that is fast-moving or that exists at particularly high scale. Quite often opening up new channels direct to customers and dealing with more things, more scale, and a more rapid pace of change. So this is the landscape that we see when we describe modern application development, and we believe that adopting the techniques and practices that I'm going to talk about in the remainder of this session can deliver competitive differentiation. It can deliver sustained competitive differentiation to organizations that adopt these models, adopt these ways of working. And of course, AWS is a super popular and incredibly popular place for organizations to try to deal with the challenges that these new trends present and build applications using these new patterns. All of the example logos that you can see on the slide behind me are AWS customer references, and you can find more information about every single one of these use cases if you spend a little bit of time on the AWS website. I'd really encourage you to do that. So what are the core capabilities that we're talking about here, and how do these core capabilities map against different services that we provide? When we talk about modern apps, we're thinking about characteristics like security, Resilience, which is of course the ability to deal with both expected failures and unexpected failures within the application or architecture. We're thinking about elasticity to scale up to deal with high levels of demand, and scale down in a way which enables us to be cost efficient and of course more environmentally friendly about the amount of carbon that we might be generating from our apps. We're thinking about modularization, about service reuse, about automation to make it possible for us to run experiments in a way which is more scalable, or reverse experiments in a way which is quicker and more responsive to our needs. And we're also thinking about interoperability. We're thinking about open standards, mechanisms that we might use for exchanging data with partners or with customers, approaches that we might take to enable us to run software in multiple different locations in the cloud and at the edge, or even in multiple different types of infrastructures. Getting to this situation often requires change for customers. So with the exception of startups, brand new startups, everyone has legacy, right? Everybody has something already that they need to transition to the cloud, they need to modernize, they need to lift and shift, they might need to update. And we see several different patterns that emerge within this transitional phase that a lot of our customers are taking today. And we provide technology solutions that match against some of these different transitional approaches. So if you're thinking about re-platforming an app, you might consider containerization and running that application on something like AWS Fargate. If you're thinking about reinventing the way in which you build applications, moving to event-driven serverless computing models, you might think about AWS Lambda. If you want to operate complex applications that comprise many different services, then maybe refactoring and using a service like AWS Step Functions is a good way to do that. And if you have apps that you want to pick up and run as they are today, but on cloud-based infrastructure, then we have EC2 to support that sort of transitional model. We have many, many customers that have taken these approaches today. One great example is Turner. It's one of the largest TV broadcasters in the US, providing both cable and satellite television channels. It's part of AT&T Warner Media. They've moved 850 applications to over 5,000 containers running on AWS Fargate, which is our container orchestration solution. It's removed the need for Turner to manage Kubernetes clusters and to deal with a lot of the heavy lifting associated with deploying, operating, and managing that underlying infrastructure substrate. And then with FINRA, this is the US analog for the Financial Conduct Authority here in the UK. So it's the North American US financial regulator. They're concerned with things like stock trade verification. They're concerned with activities like big data analytics on trading history data to try and figure out if anything unusual or unexpected might be happening in the US financial markets. What they did here was move their stock trade validation system to AWS Lambda. Now there's one important characteristic of financial markets which is very obvious. They're only open during the week from, say, 8 in the morning till 6 in the afternoon, right? So for 2/3 of the time, these applications, they don't need to run, okay? So with service platforms like AWS Lambda and event-driven application models, you can immediately eliminate wastage. You can deal with the spikes in demand that might arrive when there's a real flurry of trading activity, or you can deal with scale down to zero at those times of the day, week, or year where there is zero application activity. And that kind of event-driven model here for FINRA was able to save a lot of money. They save 50% on this really important core application, whilst at the same time improving performance by roughly 2/3. So really impactful change for FINRA as well. So let's get into a little bit more detail. We'll step through some of the items in this checklist, give you a little bit more flavor for how you can apply AWS services to some of these challenges. So we always say that security is job zero here at AWS. Whenever we create a new service, we focus on 3 core attributes: security, reliability, and scalability of that service offering. And we would never launch a service to customers, making it available to you, without ensuring that those 3 core attributes were present in that service. And of course, we believe that security is the #1 priority for customers as well. And in taking this transitional approach and changing the way in which you develop apps, you should not compromise on that. You shouldn't expect to have to lower information security and data security standards as a result of delivering applications in a new way. In fact, we feel you should be able to raise the bar. You should be able to build applications that are more secure, taking all of the accumulated knowledge of years of application development and operations and applying that set of principles, things like the principle of least privilege, to the new applications that you build. In the case of AWS, our IAM service, Identity and Access Management, allows you to support and enforce secure authentication and authorization for service access. And you can do this at the individual service component within a microservices architecture that you might choose to build. So you have very fine-grained access control over the different components of your application. You're also able to use other AWS services like AWS CloudTrail, AWS CloudWatch Logs, AWS Guard Duty, our comprehensive access logging services, to enable you to audit and govern access to both AWS APIs, that's the control plane, as well as data plane components that we might provide as managed services, things like the Amazon S3 or DynamoDB data plane interfaces, or data plane components that you might create within your own applications. You can have strong auditing and governance capabilities across your apps. And then you can provide validation capabilities that might exist during application development with services like Amazon Inspector, our application security verification service, or in life with services like AWS config rules, where you can trigger events within your security management infrastructure in response to events that happen within your infrastructure on AWS. So there's a complete suite of services there for building secure applications. With microservices, this is one of the biggest shifts in application architecture over the course of my career. I've been in IT for over 20 years and can remember working on early Java apps and thinking that that was a really good pattern for application development. And of course it was, but with the faster moving, more complex environment that we see today, it's become very difficult to maintain application development velocity and also deal with things like scaling challenges when applications run inside gigantic monolithic code bases. And we see many, many customers today seeking to break applications up into a smaller group of independent services, each of which are focused on doing one specific thing really, really well. There are some fundamental properties of microservices, things like independence, the fact that services can be individually deployed and scaled, that services can be written in quite different languages or use quite different development models or paradigms based on what their intended use case is. They're modular and of course they're decentralized. But I think that the biggest benefit of adopting a microservices-based approach is actually the change that can come organizationally as a result of doing this. There's a law in systems research called Conway's Law, and it says that the software that you build will more or less mirror the architecture of the applications that build it. Okay, so if we want to build lots of small services, it follows that we'll have lots of small teams, right, working on one or two services each. And by doing that, it's much easier to engender a culture of ownership. We always describe this as you build it, you run it. And that is probably the biggest benefit of adopting this kind of approach, that the ownership model is much clearer. You as an engineer or as an engineering team will know exactly what you're responsible for. You have a much higher degree of control over those deliverables than you might have done with other models. So that's a really, really big benefit. Of course, in AWS, we have a level of detail below this of services and design concepts that we feel that it's important for customers to consider in building applications in this way. Things like the use of managed services wherever possible, so offloading as much heavy lifting to the platform as you can, or maintaining the sharpest possible focus on writing business logic and avoiding writing code that isn't directly value-adding to your business or to your mission. Moving to loosely coupled and event-driven architectures. This can prevent latency and failures from propagating through your architecture, and it can also solve scalability challenges by allowing different parts of your application to scale independently and autonomously from one another. And then lastly, you can simplify delivery and discovery by using a combination of standardization at the API boundary, and service discovery capabilities as well. And for standardization at the API boundary, we provide a service called the API Gateway, which makes it really easy for you to establish service boundaries, map out an API namespace for your different components, and then connect that to different service endpoints that you might use to deliver changes or information about different attributes within that API namespace. So if you haven't taken a look at the API Gateway, I'd really recommend that you do that. Let's switch gears a little and talk about data architecture for a second. And one of the big shifts that we've seen over the course of the last 10 years or so is the rise of persistent data stores that have different characteristics to those that have been traditional. So we've mostly worked over our careers with relational data stores. And today, relational databases are still important, but they're becoming less of a de facto choice and more of a conscious design decision that customers will take where they are the right answer to a particular question, where you need strong consistency, where there is some definitive need for normalization. But in a lot of cases, that is not the overriding objective. And we've heard a lot of feedback from customers about the importance of having the right set of data persistence services for specific use cases. And today we provide a whole range of different data stores that customers can use within modern applications in order to build persistent data stores that have the right characteristics. And the right characteristics here, for example, might be I want to use document-orientated semantics for my data store. So here we have something called Amazon Document DB. I might want to have a graph model for asking questions about the relationships between entities as well as about the entities themselves. I might want to have time series data, or I might want to have an immutable ledger database that makes use of blockchain technology to ensure that every transaction in that database is recorded and that no transactions can be changed or deleted without it being visible to me. And that's what our new quantum ledger database does. Another big principle here is driving towards the use of serverless technology. And when we talk about serverless, we're talking about automation and abstraction that allows you to spend more time focusing on that business logic, spend less time focusing on infrastructure heavy lifting. Okay, and here we have a couple of different service options. AWS Lambda, a lot of you will be familiar with this now. Still can't believe that when we launched this at AWS reInvent a few years ago, I didn't appreciate how impactful this service would be, how big a community would be created around serverless development, and quite how it would capture the imagination of application developers across the world. And I think you could say that there's a serverless movement today where a lot of customers, a lot of developers are really excited about the possibilities that it offers. The primary attribute here is event-driven computing. Okay, so our code runs in response to events. Okay, and if you've got an application that can benefit from that, then Lambda is very likely to be a good fit for that application. On containers, we have something called AWS Fargate. This is our effort to abstract away the complexity associated with running infrastructure for containers and also associated with running container orchestration tools. With Fargate, you simply define your task, the collection of containers that you want to run, issue a command to run that, and we will place that task onto a managed execution environment for you. You have no visibility of the resources that are being used, and you'll just receive a bill for the amount of memory and CPU footprint that your task has used. There is no management of the underlying infrastructure with that model. If you need more control, then we do have a variety of other container orchestration tools that you can use. And we have other supporting tools as well, like a container registry, an app mesh for container-to-container networking at scale, including service discovery features, and everything that you need to build containerized applications. But for a lot of customers, the choice of compute is really core to this transformation, and they think mostly about where the operational responsibilities lie in selecting these different options that are available to them. You can see as you go down the stack, the infrastructure becomes less opinionated. You have more control, but you also have more responsibility, more activities that you need to carry out in order to maintain and manage those infrastructure components. The serverless architectures provide greatest agility with the least effort. And then, as I said earlier, you can put this API gateway service to work to provide entry points into your serverless applications, as well as other advanced features for things like version management and staging, the creation of SDKs for your applications, even wiring multiple different service endpoints into a single API namespace. So you could have part of your namespace served by Lambda functions where that is appropriate, and part of it served by endpoints that are running either on containers or on native EC2 resources. And you can mix and match all of those different resource types inside one API by using the API gateway. And then for those more complex multiple service workflows that you might want to build, we have a service called Step Functions that allows you to do workflow orchestration, parallelization, includes things like retry and error handling logic, and enables you to build applications that are, in essence, a sequence of processing steps managed by a Step Functions workflow. Third important area here is infrastructure as code approaches. And this, again, is something that's really taken the software development and operations professional community by storm over the course of the last few years. We've seen many customers move towards models where they only provision resources using infrastructure as code tools, either our own CloudFormation tools or other services that exist out within the AWS ecosystem that provide similar features. And this allows you to version control, to manage and maintain your infrastructure resources alongside your application code. So you can make a change to infrastructure in the same way that you might make a code to make a change to a code branch within a source control repository, and then you can trigger a build of infrastructure and software as one operation, allowing you to do things like establish test coverage over infrastructure, or move towards declarative models where rather than writing a series of steps to provision resources, you specify a target state for the resources that you want to see within your environment, and then tools will provision resources for you to help your environment move towards convergence on that target state. This is what tools like CloudFormation deliver to customers. Makes infrastructure changes repeatable and predictable. You can do those releases of infrastructure and software as one job, one integrated workflow. It also makes it very, very easy, as Anne's going to show you in a few minutes, for developers to spin up their own testing or work environments, enabling them to test on a replica of production, an exact replica of production, with no chance of drift. So a developer can be certain that the environment within which they are doing their testing is entirely consistent with the prod environment where the code is going to end up once they push to production. Really, really powerful tool. Now, for serverless apps, we released something else a couple of years ago called SAM. This is a further abstraction that is built on top of CloudFormation, which is an open source framework. It's intended specifically for defining and deploying serverless applications on AWS. And what we've tried to focus on here is simplification. So taking the resources that are most commonly deployed within serverless apps, things like Lambda functions, IAM roles for those fine-grained access control security models that I talked about, API gateway endpoints and namespaces, and simple persistence stores like DynamoDB tables, and creating a really simple to use definition language so that you can provision those resources. Writing an application can be as simple as just a few lines of YAML, provision that through the SAM engine using the command line tools that we provide, and that will package up and deploy your application, your application source, and create all of the other resources that are defined within that SAM template. It's the simplest way to get started with serverless applications on AWS. And if you're not aware, we also announced something for this called SAM Local, which enables you to spin up a replica of the execution environment on your laptop and build and test serverless applications locally, and even do so in disconnected mode. And then even more recently, we announced a plugin for VS Code, Visual Studio Code, which enables you to automate all of those activities directly within the VS Code IDE. So you can build, test, deploy, and run local serverless applications directly in Visual Studio Code today using a combination of SAM and SAM Local. To further extend the Lambda ecosystem, we also have something called the Serverless Application Repository. This allows you to templatize applications that have been defined using SAM, load those into a discoverable set of repositories inside AWS Lambda, inside the Serverless Application Repository, and then reuse those applications across your organization, or even share those applications with other organizations that might be external to your company. There's already a large number of templates there available for you to use. You can plug in, pick up, and use other developers' code. But of course, you can also see precisely what you're deploying in your account and have complete visibility over the applications and resources that are being created for you using this tool. I want to move on now and talk about CI/CD tools. And this is a really, really important area. So the first important data point is that organizations that have continuous integration and continuous deployment capabilities are able to ship more code more quickly and to do so in a way which gives developers higher confidence. Often these tools are integrated with test-driven development capabilities to enable developers to continuously check code in, have that code continuously integrated, and have automated testing coverage for the code that they are developing, for the code that they are writing. In the modern application landscape, we tend to move away from this idea that you'll have one delivery pipeline for your application into a model with many more pipelines, typical to have one pipeline per service. Okay, so we're going to break our application down into independently managed and delivered components. And each team can have its own continuous integration, continuous delivery environment, enabling each individual team to build, test, release, and monitor their own service independent of the other services that might comprise the overall application landscape that we're talking about here. And to talk a little bit more about how one of our customers has built this kind of system and show you how it operates, demo God's permitting, I want to invite Anne to the stage. Anne, please. Thank you.
Thank you, Ian. Hi, everyone. So I'm going to talk to you today about how we use AWS to enable rapid innovation at Sage. But who are Sage? So we support businesses of all sizes, and we help them handle everything from money to people. And to give you an idea of scale, we're a global company. We employ 13,000 people, and we have a lot of responsibility globally. If you look at some of the figures on this slide here, what really stands out to me is the $4.2 trillion annually go through our software. That's quite a significant impact on the world economy. And then also, here in the UK, about a third of the UK get paid through our payroll software. So that's 1 in 3 of you is most likely paid via Sage software. So we do a lot. And where does my team fit in? Well, delivery enablement and builders tools is really about enabling the colleagues at Sage that work on software solutions for our customers, really giving them the best environment in order to be able to innovate. And we do that through providing tools, guidance around continuous delivery, for example, and we also provide reusable components and templates, blueprints, so that our teams don't have to think about reinventing the wheel, but instead really focus in on delivering customer value. So now, demo God's permitting, I'm just going to make sure that this is on. Yes. 1 second. Lock screen. Can we switch over to demo? There we are. Right, so here, as Ian was taking us through earlier, this is essentially a stack definition in YAML. And I've been working on a feature for a little while. I've been adding a new API endpoint in, actually. I've been adding this rates endpoint here. and now I'm ready for someone else to look at it. And so I'm going to do something that an awful lot of developers do from time to time. I'm going to raise a pull request. Now, the developers in the room who are quite familiar with what I've just done there is I've just basically said, hey, someone else, come and have a look at what it is that I've done. Usually just a code review, but if we leverage Amazon, automation, and infrastructure as code, what we can do is we can create a manifestation of that pull request in Amazon directly. So we actually have a carbon copy of what would go into production if that pull request is accepted, in theory. So, just have a quick look down. Did I actually? Oh, I haven't raised it yet. I do apologize. Terrible, I haven't created any comments on it or anything. Okay, so what's actually happening in the background now is we're going to, first of all, create a stack that relates to the pipeline for the pull request, which is creating now, as you can see. And then that pipeline is going to appear here at some point. While we're waiting, because these things can take a few minutes, can we just jump back to my deck? Cool. So what am I actually deploying here? So I talked about it a little bit. I'm actually deploying a serverless API, and I am deploying essentially a repo which I created from one of our quick start blueprints, which is essentially the application code, the infrastructure as code, so the envelope that sits around the application, any boilerplate test code, but also, very importantly, the delivery infrastructure as code as well. So everything is code. And you can think of a quick start blueprint as a reference architecture plus. What it does is it's better than a standard reference architecture where it might be some presentation or some document or some set of standards that you have to read through, because it's code, right? So it's code, and it's kept up to date in the same way as code is kept up to date. And say, for example, if someone in another team thought, I like your reference architecture, but it would be better if, X, Y, and Z, or I've noticed this isn't quite standard here, they can submit a pull request in the same way as I've just shown you. So it really is a living thing. The other thing that it can contain, if you're a company like Sage that's obviously got a lot of regulatory responsibilities, is you can codify your standards in there. So you need to do your security, you need to do X, Y, and Z. And when people come along, pick up that starting point, they're compliant. They're standards compliant already, and they can just focus on what the extra thing is, which is really nice. Okay, so can we come back to demo? Okay, so I'm going to see if our pipeline has been created. There we are. So just to show you, by the way, this was pull request 21. So this is the bit where I said there was nothing up my sleeve beforehand. So this is pull request 21's pipeline. Now, we've simplified this for the sake of demo, but you can see here that we did some CI, and then we did some provisioning, and we've now, actually, we're still in progress, so we're currently provisioning the infrastructure, or actually creating the change set to provision the infrastructure, and now we are creating the infrastructure that relates to this pull request. So that's still running. So I'm going to explain a little bit more about the why. So I already spoke to you about the fact that developers raise pull requests all the time. But when you do this, you can enable other types of review and other types of use cases. So you can enable a review by somebody who isn't necessarily a coder. So you can enable a review by a subject matter expert. At Sage, that might be a compliance analyst, something like that. You could enable a review by a product owner, somebody in marketing, a partner, a trusted customer even. Is this the feature you were expecting? Okay, so this is where we come back into CloudFormation and have a little look as to what stacks we've got now. Okay, so you can see the stacks. Oh, the stack's there, and it's been created. I'm going to just show you, now just scroll down for a bit, just exactly how much Amazon was doing on our behalf there. Amazon was doing some serious heavy lifting while we were just having a bit of a chat. And what did we get? We got an API, and we got an API with a new endpoint called rates. We'll take a moment because of Lambda startup. There we go. We've got a new API returning some JSON. I've been asked to look at this. I'm ecstatic. I love this API. This is the best API I've ever seen. So I'm going to come back into GitHub, and I'm going to say, yep, love it. Good. OK. If I just come back to my API, come back into the stacks, let's have a look at the stacks. Give it a refresh. We can see now that we've checked everything was cool. We no longer need this stack anymore. So now it's going away. So we're making really, really good, cost-effective use of our resources here, and we're cleaning up after ourselves with minimal effort, just by doing what we were doing. You see what I mean? And I think that's really powerful, because that enables us to continue to innovate and to continue to, spend time working on new features, experiment. Back to the slide deck. Thanks. OK, so I did have this, just in case it all went horribly wrong, so I'll just come past this. I'm coming back to what Ian was saying about that innovation flywheel, getting from idea to feedback as quickly as possible. That was pretty quick, wasn't it? I think you'll all agree. I'm just trying to think about what that would be like if you didn't have Amazon. Actually, that's like months and months of work. And then thinking about not having to deal with the collateral damage of failed experiments. That just cost us, if that cost us anything, it cost us pence to run that particular experiment. So that was all that I was going to say, really. I'm going to hand back over to Ian. But well. Thank you.
That was awesome. And actually takes a lot of guts to get up on a stage in front of like 2,500 people and do a live demo like that. So thank you very much, Anne. I really appreciate the work you put into that. 5-minute overrun. We're going to kill some observability now very quickly before we wrap up. So this is a really important thing. I think maybe one of the sort of the dirty secret of microservices is that not everything in the garden is completely rosy. In return for that upside, there's also complexity that is introduced, okay? And one of the areas of complexity that exists when you break up your monolithic application into a set of independent components is that you can no longer stick an APM tool into your Java runtime and have complete visibility over the world, right? Because the world now comprises different independent services. Many of those independent services could be ephemeral. There's no concept of on-host logging with AWS Lambda because there's no concept of a host. Okay? Just like in EC2, if you're using simple constructs like auto-scaling groups, log aggregation and centralization is absolutely critical because you've got no guarantee that a particular machine will be there when you come to do your forensics or application performance diagnostic work. You don't know whether the resources will be around or not. They're getting created and destroyed on demand in response to events, right? So we need different approaches for monitoring and observability. This is a hot area in cloud computing today because it's an area that is still somewhat emergent. In AWS, we have a service called X-Ray. And X-Ray enables you to do tracing. So you can inject an SDK component into your application, and from that SDK component, you can instrument your application. You can instrument calls that your application makes to other services, and indeed other SDKs that support common HTTP or HTTP request libraries will benefit from automatic instrumentation. In the case of Lambda, this is automatically integrated. We inject the X-Ray agent natively into AWS Lambda, and it gives you some incremental features like the ability to observe and time cold starts, so you can figure out what the cold start characteristics of your application might be, and of course, through that visibility, you can work to minimize that issue. You can also pinpoint issues in downstream services and see latency in near real time. Traces appear in the AWS X-Ray console in just a few seconds. You'll get this automated graph-based topology for your application, and the rings around these services are significant. So the yellow and red rings, if you see them, will show error rates. In the center of the circle, you can see average latency, and you can see transaction throughput, transactions per minute or transactions per second, depending on the level of volume that is being driven through the service. And then for each individual trace, each individual logging instance that you have in the service, you can further drill into that, and you can see a time sequence-based latency chart for your application showing sequential and parallelized execution components inside this particular invocation of this particular function. So you get really granular capabilities to investigate, interpret and understand precisely what is happening within your apps. You'll also notice here we've got an example that uses Amazon Rekognition, our deep learning powered image analysis service. The other AWS services are auto-instrumented. This is because we use the libraries within our SDKs that are supported automatically by the AWS X-Ray SDK. So you can see things like downstream traces, and you can also correlate events from API calls within your application with logging data directly within the X-Ray console. Here we can see that we had an error message that was returned by recognition because we invoked the endpoint with an invalid image format. We didn't send it a PNG or a JPEG, so it was unable to run the model and unable to evaluate the image that we provided. So if you're doing development in Lambda or development in one of the supported languages for X-Ray, of which there are many, it's well worth taking a look at the X-Ray SDK. Very simple to inject it into your code base, start to collect instrumentation data, and evaluate whether or not this service is valuable for you. I personally use it in all of the demos and application development that I do within Lambda today. And then lastly, on service discovery, we announced a service at AWS reInvent last year called AWS Cloud Map. And this solves for the service discovery challenge that exists within this distributed architecture that I've talked about, helping you to discover services with specific attributes, integrating capabilities like health checking, and enabling you to take advantage of a highly available DNS-based service mapping and service discovery capability for your applications as well. So, I hope that's been a helpful tool around some of the considerations that you need to bear in mind in developing, deploying, and operating modern applications with AWS. I want to thank you for joining the session. Also want to thank Anne again for her participation in her excellent demo. You can rate this session by using the AWS mobile app for today's event. So please provide us with some score. We're always interested in getting feedback and understanding how we can improve. Thank you.